जो क्या हो गया भाई? सब गायब है। टुडे नो वन वांट्स टू स्टडी। चलो अपन स्टार्ट करते हैं, तो लेट हो जाएगा, है ना?
ओके सर।
आई थिंक, क्योंकि मुझे लगता है आज क्या है, 13th है ना? 14th 15th है ना? परसों छुट्टी है ना? बीएमसी की छुट्टी है तुम्हारी परसों, दीवा?
सर मेरी यस सर 15th को तो है।
15 को तो है ना? हरिप्रिया ज्वाइन कर लिया, आप हरिप्रिया भूल गए हो। Slowly they will join.
Sir, I
हम्म
lost track of time while studying.
अच्छा, you were studying. Okay.
Yes, sir. Tomorrow I have the last exam.
That's why I message everyone, because you may forget sometimes. अच्छा, हाँ, in the last class they will join. Equation of chord and everything. Equation of chord we have done, na? Equation of chord with midpoint, yes, okay. Acha. Now let me tell you about few of the cases. Condition of different conditions, actually I wanted to say. Let me change the color. See, there are few conditions. Important conditions. Conditions are when there are two circles, suppose. Circles are touching each other. If two circles are there, they are touching each other. They can touch in two different ways. One way is this. I'll make one smaller circle. Nowadays, actually, everyone is having exams. In this case, the circles, these are touching. If this is the center is C1, this center is C2. The radius of the first circle is suppose R1. The radius of second circle is suppose R2. They are touching externally, means first case is this. The condition that you will make is C1 C2 is equal to R1 plus R2. कनिष्का का मैसेज आया, 6 मिनट में ज्वाइन करती हूँ. ओके, कॉन्सेप्ट मिस कर जाओगे. They are touching externally. This is easy to find now. When they are touching externally, C1 C2 will be equal to R1 plus R2. C1 C2 is the center, means you can find out C1 C2 by using your distance formula. Okay, easy. The
Yes, sir.
second case is when they are touching, they can touch internally also. That's another case. The internal touching means this is one circle, the second circle will be inside, right? Here this is C1, this is C2. The radius of this circle is R2. The radius of this first circle is suppose R1. Here, what will be the condition? C1, C2 will be equal to R1 minus R2.
R1 minus R.
Very good. This is easy to understand. Now, there is one more condition. The condition is when they intersect. This is for the touching. This is for when they intersect. Now, when these two circles are intersecting, I'll give you a formula also, very good formula, which will be very beneficial to you. Two circles are there. Actually, they are intersecting means results will derive from this. These are two circles. This is the center. Obviously, they will be intersecting at 2 points, P1 and P2. In that case, if you see this distance, C1, C2, this will follow, will be lying between R1 minus R2 modulus R1 plus R2. Because they are intersecting, means this center will always be less than R1 plus R2. Okay, na? But it will be greater than R1 minus R2. This you can observe through observation only, you can understand. R1 minus R2 means it's completely inside. R1 plus R2 is completely outside, just touching. And in between anything is possible means they are intersecting. Okay. When the circles intersect, in this case, and they are not, if they are not intersecting, circles are not intersecting means you can have again two conditions. Either this is the case, this two circles are there. They're not intersecting means the C1, C2 C1, C2 will be, if they are external, C1, C2 will be greater than R1 plus R2. Okay. Or the second case is when they are inside. The other condition you can frame like that. One more thing important to this is in both the cases this will follow, either they are outside or they are inside also. Acha. I'll tell you one more thing in these cases. If we want to find number of tangents here, if we want to find number of tangents, when they are touching externally, how many tangents we can draw? In this case, 3, na? One this, one this, and one this one. When they're touching externally. And when they're touching internally, you can draw only one tangent. Easy, na? Everyone, you are able to follow? Easy things. When they are intersecting, you will be able to draw only two tangents here. They may not be parallel because I have taken the size of both the circles almost same, but there will be two tangents only. In this case, when they are not intersecting, you can have four tangents. When they are inside each other, no tangents. Actually, I need not have to tell this one, but you can derive by yourself only. In this case, can you tell me in this case how many tangents we can draw?
So 4.
One will be this, other will be this, one will be this, other will be this. Number of tangents, 4. One more thing I'll tell you. See here in this case, there is very important, very good result. When suppose if I said the equation of circle, equation of this circle is S1, equation of this circle is S2. Example, S1 I have given to you. S1 is equal to x square plus y square plus 2g1x plus 2f1y plus c1 is equal to 0. S2 I have given x2 x square plus y square plus 2g2x plus 2f2y plus c2 is equal to 0. The common tangent, na, this one, this common tangent is given by S1 minus S2 is equal to 0. Only this one, only the common one I'm talking about. Common tangent. Okay, this one is given by S1 minus S2 is equal to 0. Meaning what? If you do S1 minus S2 is equal to 0, you will get 2 into G1 minus G2 into X plus 2 into F1 minus F2 into Y plus C1 minus C2 is equal to 0. This gives you the equation of common tangent. In this case also, this is the short one, the short result, which will be helpful for you for finding out the common tangent. Because see, normally if you find out the equation of tangent, you will be solving it, you will be finding out the point where they are touching, and then you will use the equation of tangent xx1 plus yy1, that shortcut I have given you, that thing you will use, and then after using that you'll find out the tangent. That's a bit lengthy. But in this case, finding out the common tangent becomes easy if you know S1 minus S2 is equal to 0. Here also, if they are touching internally, you can use this S1 minus S2 is equal to 0 result to find out the equation of common tangent. Okay. But here in this particular case, when the circles are intersecting, the common tangent, this S1 minus S2 gives the line, the chord to each other. Okay. This green chord, na, green one, which is chord to the one circle and the chord to other circle. This equation is given by S1 minus S2 is equal to 0. Got it now? Here, when the circles are intersecting, there is one more result. When the circles are intersecting, when they are intersecting, you are asked to find out the angle between the circles. Because it's very difficult to draw this diagram again and again, I'm doing it here only. Angles between the circle means the angle between the tangents. So you are able to follow now. I'm not going fast. Everything is understood now. Easy.
Yes.
Hmm. Haripriya, Shama.
Yes.
ओके, क्या तुमने थोड़ा सा पार्ट मिस कर दिया है? जो पार्ट मिस हुआ है उसको एक बार देख लेना पीछे, बहुत कुछ नहीं हुआ है वो, जब तुम देखोगे तो इजीली अंडरस्टैंड समझ जाओगे। कुछ चीजें मैंने बताई हैं तो उसको एक बार देख लेना है ना। वैसे जो भी चीज बताई है वो मैंने एक्चुअली क्वेश्चन जब कराऊंगा तो उसको समझ में आ जाएगा। ये बस टचिंग एक्सटर्नली और इंटरनल टचिंग की जो कंडीशंस है वो सब मैंने बताई है। Here see, when the circles are intersecting, angle between the circles is asked. When angle between the circles is asked, that is actually nothing but angle between their tangents. Now here the tangent, if you want to find out the angle, this tangent, the first one on the first circle, and this tangent on the second circle, the angle between them is theta. How you will find? But this is radius r1, this is radius r2, this is c1, c2. If you use that formula, triangle formula, you remember that formula I gave you. When a triangle is there, this is A, this is B, this is C, this angle is C. In that case, you can, this angle is theta, suppose, and you can write C square is equal to A square plus B square minus 2AB cos theta. I have given you this formula, no? Do you remember this one? Cosine rule. If you do not remember, remember this. This is theta 1, this is theta 2, this is theta 3. You can use the same formula for other results also. You can also write it as A square is equal to B square plus C square minus 2BC cos theta 3, or B square is equal to A square plus C square minus 2AC cos what theta 2. See, now this information we have to use here. When you use this information, you will write this formula C1 C2 whole square is equal to R1 square plus R2 square minus 2R1 R2 cos theta. What sound actually? Looks like some werewolf has come. Wait, wait, wait. I'm coming, just 2 minutes. 2 minutes. Hmm. Drilling sound. Okay, this is the result. This is how you find out the angle between the two circles. Okay,
Yes.
clear to everyone? Now I'll be giving questions on this. Just look at this. I'm selecting some questions for you.
This is we learned in 10th, sir.
This one, na? Cosine rule.
No, sir, the whole thing.
Whole thing.
Ah.
Not possible, Shyama.
No, sir, like, I.
Common tangents and all.
Yes, sir. This thing and all.
Common tangents is easy, but these formulas I gave you, na? This S1 minus S2 is equal to 0. This you must have not learned.
We learned, sir.
In
In,
10th?
ah.
Very good. So try this question. This is supposed to be easy. Just rectum. How? Achha, I'll give you a very good question. Good one. It's good one. The question is, Acha, sometimes they ask you a condition for orthogonality also. Orthogonality means this theta is 90. Okay. Orthogonal means circles are orthogonal means this theta becomes 90 degree. This is the only thing. So cos 90 will be 0, that you know. Accordingly, you can put this condition. Okay. Now try solving this question. Then after you solve this question, I'll give you the question that I wanted to give. Try solving this one. Okay.
Sir, how will you find the radius?
Radius. This distance you will use, no? See, they said they're intersecting. The point, the distance of the center with the point of intersection is the radius. This is one circle. This is another circle. Now see, why I have told this is condition of orthogonality. So you asked me how we'll find out the radius. Because in the question they have given now, the circles with equal radii, the radius are equal, they are intersecting at point 0, 1. This is 1 point 0, 1 and the other point is 0, -1. Acha, how will you find? Yes. You assume something. Okay, I got your point. How will you find out that? See, one important condition is if the tangent to this circle, if tangent to one circle what passes through the center of the other circle. Let's say this tangent, the tangent that I have drawn, this is the tangent to this circle. Okay. This tangent is passing through the center. That means what? And they are intersecting. That means what? This, and if we join, the radius is same. If we join this with this will be the radius. Okay. Now, if they are intersecting like this, tangent to the one, this first this C2 circle passing to the center of the other circle, then they must be perpendicular. Na here, actually, I forgot to tell something here. In the above case, these two tangents, the tangent to one circle may not be perpendicular to a radius. It's normal. It's not not important. But here they have said the tangent to one circle C2 is actually passing to the center of the other circle, meaning radius are same. Both the radius are same. That means this radius, green radius, and the pink tangent, they should be perpendicular. Radius and the tangent has to be perpendicular, no? Because this is the tangent. The red one is the tangent to C2. So the radius of C2 should be perpendicular to it. Okay, Haripriya? So this angle is 90 degree. Okay. Now you have to assume something like minus alpha comma 0, and this is alpha comma 0. This is radius r. Then here 2 alpha whole square should be equal to r square plus r square. 2 alpha whole square is equal to 2r square. I'm getting. one more condition you can use here, Priya. This is one condition you have got. Other condition that you can use is 0, 1 lies on first circle, any circle that you can use. X minus alpha whole square plus y minus 0 whole square is equal to this r square. 0, 1 lies on it. So alpha square plus 1 square is equal to r square. Alpha square plus 1 is equal to r square. This is the second condition. Now using this first and second condition, you can find out the radius. You understood how do we find out the radius? Haripriya, tell me, is it okay?
Yes.
Actually, I have almost solved this question. This is 4 alpha square is equal to 2r square. Let me solve it completely. R is equal to root 2 alpha. So, or r square is equal to 2 alpha square you are getting here. 2 alpha square plus 1 is equal to 2 alpha square. Alpha square is equal to 1. So, r square is equal to 2. R is equal to root. Answer is A. Okay.
Sir, you found out the radius. They've asked C1 and C2.
C1 distance between the center. Ah, then I got the answer wrong. C1, C2 we can find easily now. C1, C2 is what? 2 alpha. C1, C2 is 2 alpha. And alpha is 1. So 2. So the answer is 2. Now let me, now I'll check the answer. Answer is D. Correct. Okay. Clear to everyone or anyone has doubts? See this alone, this line, tangent to the at the point to one of the circles passes to the center of the other circle. This is important. This makes this angle as 90 degree. In our general case,
Sir, if the answer would be 2, wouldn't it be just like R1?
but R is not 1, na? R is root 2.
Yes. Hmm.
Clear? No one is saying anything. Is it confusing to everyone?
A bit.
See the difference? I know where you will be getting confused. This line is important. Here, the above the case that I've given you, where is this? This one. Here, when we have discussed the angle between the two circles, these things, the radius r1 may not be the tangent to the radius r2 at the point of intersection. That's important thing. When the angle between them is theta, r1 is not the tangent at the point of intersection to the circle C2. If it was tangent, if this R1 was tangent to the other circle, then this radius R2 and radius R1 would be at 90 degree, because you always know in a circle, the tangent and the radius are always at 90 degree. Correct? But here, it's not necessary that this R1 is tangent at the point of intersection to R to the circle C2. That's why this is the point where you are getting confused, because you are in our diagram, you are thinking this diagram and that diagram is same. And here here sir has told this angle is theta, why he is taking there 90 degree, right now?
Yes, sir.
But in this case, he has said that this R1, he that in our question, he particularly said the radius, the tangent to the circle C2 is passing through the center of the other circle. That means what? The radius R1 is the tangent to the circle C2. That makes it clear, when R1 is tangent to the circle C2, that means R1 should be perpendicular to the R2. But in this case particular, it looks like R1 is the tangent to R2 here, but it's not. R1 is not tangent to the other circle. It's not the tangent. It's just a line connecting the point of intersection to the centers. This R1 is never a tangent. I never said this R1 is tangent to this other circle. Don't confuse here. It's not a. It's this R1 is not a tangent to the circle C2. Okay, it's just a line connecting C1 to the point of intersection. You may extend that also if you want. Okay. The confusion is in the diagram only. Otherwise, if I would made this different way, this may have extended into the circle like this. Now you won't get confused. Okay, it's clear now. Why did I give this question? Otherwise, you would have not got confused. Okay, clear it is.
Yes.
Wanted to give that one. See this one. See it properly. If you want me to draw the diagram, I'll draw it for you. But first understand by yourself. Actually, before this, I wanted to give you one more concept that I think I have did. One concept I wanted to give you. It's a small one. Not related to this at all. Concept is not related to this. Condition of a point lying inside the circle, outside the circle, or on the circle. October. I say you attempt this question only, I'll tell you later. You keep on solving this question, writing it, writing the other thing, other concept. These three conditions you wanted to say. This is outside, this is on the circle, and this is inside. So did you understand this question? This one? Actually, how these circles are, one is like this, other is like this, it's touching. The third one is like this. But still, I have to draw it more properly. Like this. And these circles are actually touching the x-axis. Okay. The smaller one will have the radius a. Its radius is a. This radius is b. And this radius is c. They are actually touching everyone. They are touching this axis. Hence, if you want, you can easily write this is b. It's pure geometry. This is b. This is a. And this will be just c. They are touching at these points. X-axis is the common tangent. Then you have to find out the condition between A, B, and C. It's a very good question. It's a good one. But this question does not involve any of your extra concepts that I have just given you. Just the basic common sense and your Pythagoras use of your Pythagoras theorem and all, you will be able to solve this question. Okay, just you have to make sure of this, means just connect them like this. connecting them and trying to get to the some result. Because see, I'll give you a hint. This length, this one, this is B, this is A. So this whole length will become your B plus A. This is B, this is C, it will become B plus C. This is A, this is C, it will become A plus C. Got now? Something like this, you have to make use of geometry. Make a big diagram in your notebook. Try to see what relations you can form using your geometry and see if you can arrive at some condition between A, B, and C. Okay? Take it as a homework. I won't tell you which kind of triangle you will form. That's where your thinking lies. Okay, let me give you this triangle now. You will make use of this triangle ultimately to find out the relation. Now it's up to you how you will do it. Okay, I have given you enough hints. Let's end the class now. Understood now? This is your homework. Try to do at home. Bye bye.